All right, I apologize for stopping the video so abruptly for the first part. I didn't realize there was a time limit on these videos. So I'm going to finish up with this last example problem, and then I'll show you the practice problems that I want you to do in the notebook. So we were just talking about two variables when I have one of these special cases. This one right here looked just like the last the difference of squares problem that we've seen before. But sometimes it's not going to be as nice and neat where I've got both terms in my binomial are perfect squares, right? Sometimes I'm going to have to do some extra factoring to get it to that point. This is really similar to some of the problems that you saw in the last lesson, where you had to factor out a greatest common factor first, and then you can start using some of the other factoring rules. And we're going to go ahead and do that with this one. So in this case, I'm looking at this problem, and I automatically, when I first look at it, I see this 3 and I know, okay, it's not a perfect square. So that means that right off the bat, I can't use difference of squares like I have been able to do with some of these other problems. But that doesn't mean I can't use the difference of squares rule. What I do see is that each of these terms have some things in common. They have some factors in common. The coefficients, 3 and 12, both are divisible by 3, so that means they both have a common factor of 3, meaning I could pull that out of my binomial. When I look at the x terms, I can see x cubed and x, they both have an x in common, so I can do the same with the x. I can pull it out, I can factor it out of this binomial. And with the y terms, they both have a common y. So this right here is our greatest common factor that I'm going to divide out of every piece of this polynomial, and then I'm going to see if I can use one of my special rules. Once I do that, I'm going to start with my 3x cubed y. If I divide 3x cubed y, I'm left with just x, and that's because 3 divided by 3 cancels out. It's x squared. X cubed divided by x, it leaves us with x squared, and y divided by y cancels out. The second piece will do the exact same thing. 12 divided by 3 is 4, x divided by x cancels, and y cubed divided by y is y squared. Now that I've done that, I can see that this binomial that's left is indeed one that I can use the difference of squares on, because I have a perfect square here and another perfect square here. So now all I have to do is find the square root of each of these terms, and then put them into my two new binomials. I'll start by rewriting what I've factored out. That will still be part of my answer. However, this will now turn into x plus 2y, x minus 2y, just like we did before with our difference of squares. Okay, so sometimes you'll have to do a little work to get to the part where you are using difference of squares, but that doesn't mean that you can't use it. Always, whenever you approach any problem that says factor this polynomial, factor out the greatest common factor first, and then start working through what other strategies you can use. That way it's the most factored form, okay? All right, so we have gone over in the last part 1 and now the end of part 2, different types of special cases. We talked about difference of squares, we talked about perfect square trinomials, how to identify if it is a perfect square trinomial, and if it is, how we can factor it, and then we also talked about things where I might have two variables. What you are going to do now is you're going to go to the next page, the page that is right in next to this note taker, and you are going to do 10 practice problems. What I'm going to do is I'm going to put this on the screen. You can see all 10 problems here. Maybe if I pull it away, you can see it a little bit better. What I would like for you to do is go ahead and pause the video now where you can see all 10 problems and record them on your page and start factoring. Every single one of these is going to be one of the special case polynomials. So you'll either be using difference of squares or the perfect squares, trinomials. Keep in mind you might have to factor out a common factor first, and then you can start factoring each of those trinomials. Once you're done, you can end the video. Just what I do ask is that you pause this section so that you can see each of the problems as you're working through them. Okay, once you've written them down, that's when you can end the video. I hope that this was helpful. If you have any questions, I'm going to be back at school on Monday, so you'll be able to ask me then. We're going to do a little bit of extra practice on these factoring special cases before we get into the test. Don't forget that the test is Wednesday, and if you haven't already, please make sure you turn in the 7-6 enrichment and your spiral review so that those can get in the grade book. I hope you have a great weekend, and I'll see you on Monday.